Hello, students. Mr. Murphy here. I'm sorry I'm not in class. I'm going to be missing a lot of classes this from now until the end of the year because we're doing stuff at the district level that I'm a part of. So I'm going to be missing 1 or 2 days almost every week. But I'm still going to expect everyone to keep up. All right. So if I'm teaching you or not, you will be expected to learn the same as if I weren't there, because it's only going to be like one class or two classes that I'll miss. All right. I'll have a video going through the lesson as usual. Uh, so when you're on your own, read through the lesson objectives and take notes. One really cool thing about Nearpod is not only you have this button, so it'll read stuff for you, but you've got this little arrow here so you can take notes. Okay, so if you click that, then you could take notes directly in your Google Drive or email them to yourself. All right, and that also is this button right here, just pulls it right out. All right, so um, keep up, take notes, it'll actually be better for you. There's always the lesson objectives. I spelled the lesson wrong. There's this, how do you know if you know it? And then there's the language objectives, what should you be able to say or write, right? So this lesson is just kind of review of linear and nonlinear. And there's three things we want to look at, or actually four things. There's a graph, a table, an equation, and word problems. All right, so you're going to have to recognize if a relationship between two numbers, the y and the x, are there, um, if it's linear or nonlinear. So we started with the proportional relationship, and this was in seventh grade, and that was y equals kx or y equals mx. And we knew it was proportional when we had a straight line going through the origin. So we had a point at the origin. This is exactly the same as our linear equation, y equals mx plus b, except the b is 0, so we just drop it off. But it's got a couple other peculiarities, and it's a little easier than straight linear equations. When you're looking at the equation itself, it should be able to write as y equals a number times x. And then the graph is easy. It's a straight line going through the origin. The constant of proportionalities, or the slope, is the letter m, which would be a number. But the slope in this proportionality stuff is just y divided by x. So if you're given a table and you take the y value and the x value and you divide, you always get the same answer. Or in any linear equation, if the x values go up by 1, then the y values will go up by the slope, or a constant amount, or sometimes decrease if they're going down. All right. And then in word problems, it'll always say something like a constant. He walks at a constant speed, or they're driving at a constant rate. So they almost always will have the word constant or something like that in there. All right. The slope intercept form of the equation, y equals mx plus b, exactly the same, except here we're going across the y-axis at whatever point it is. On this line, it's 3, but it could be any other number except, of course, 0. All right? It is still a straight line. So basically, almost everything is the same. It gets a little more complicated in the table part. So if you can write it, m being your slope and b being where you cross the y-axis, called the y-intercept. If you're looking at the table, if you divide the y by the x, you will get different numbers. But if the x's are going up by 1, then the y's will still go up by the slope. They'll always go up by a constant amount. That's how you'll know it's linear. If the x's are not going up by 1, you have to do a little extra work and compare the points. So you use the slope formula and you compare, you take two rows on the table subtract the y's, and then subtract the x's, and put them in a ratio or a fraction. And if it's always the same, then that's your slope. Because remember on a graph, when we looked at it, the slope, we took a point, we counted up, and we counted over, and that was our slope. Going up is the y values, so we subtract those to find how far it is from one to the other. Going over is the x value, so we subtract those to find out how far we're going over, and we put it in the fraction because the slope is a ratio of how far you go up to how far you go over, which is a fraction. Okay. The y-intercept is if you're lucky and on the table the x is 0, then whatever the number is for y, that's your y-intercept. If you don't have it, but you find the slope from the table, you put that in your equation, y equals mx plus b. You take any point on that table, you take the x value and the y value, and you put it in that equation. So now instead of y equals mx plus b, you replace the m with the slope, you replace the y with a number and x with a number, and now you just solve for b. And whatever that is, that's your y-intercept. Okay. In an equation, it will still again have something to do with constant. But it may be a little different. It may be you start at something and then you go up by the same amount each time. So like if you're renting a boat, they might say the price is $10 plus $3 each hour. So that 10 is your intercept, the B part, and that $3 each hour is 3 times X, X being the number of hours rented. So your word problems will have something along those lines in a linear equation. Nonlinear equations are pretty easy, but there's a bunch of them. So I've got a bunch of examples of what they look like, and the type of equation is at top. Y equals x to the power of 2 is a parabola. And then the cubic function, y equals x to the power of 3. And there's a bunch of them. Then there's y equals x to the 4 is kind of like the y equals x squared. And then y equals x to the 5th looks kind of like y equals x to the 3rd. So there's a pattern here. Every time the x is a power that's even, it's a parabola. Every time x is a power that's odd, it's that hump. Then we have two extra ones called, one is the exponential equation. It's where you have a number raised to the power of x. And so this one is like a really steep slope, just kind of goes up. And then we have what they call the inverse function, where x is in the denominator. So it's like 1 over x. And so this is actually two lines. It's got a curve here and a curve here, and they're just avoiding the middle somewhere. Okay. Obviously on graphs, they're all easy to find because they're not straight. That's what not linear means. On a table, it's a little bit different. If the x's are going up by 1, it's nice. You can see there's not a constant change in the y's. It'll go up by like 2 and then 3 and then 4 or something like that. It'll go up by a different amount every time. The equations are actually pretty easy. So if x has an exponent that is not 1 or 0, or if x is the exponent, or if x is the denominator in a fraction, then it's not linear. That's all we have to worry about. And then there's one new thing. So we're going to do volume formulas. And I'm not worried about this. It's really easy. Okay. So write down the formulas because you'll need them for the quiz. Remember, pi is this weird shape here, and it's 3.14. But formulas are super easy. You can use a calculator, or because we do these all the time, if you Google, if you say, what's the formula for the volume uh, of a cylinder, this comes up. And you can put the radius in the box, you can put the height in the box and hit enter, and it tells you the volume. Okay, so it's really super easy. Just be careful when you're doing these questions that you're paying close attention, because sometimes they'll give you the diameter, which is twice as long as the radius, or sometimes they'll start with the volume and say work backwards and find the radius or the height. So read the questions carefully. So this is the cylinder. This is the cone, which is the same as a cylinder, except you're dividing the height by 3. It's basically a cylinder with 1/3 of the stuff missing. And then there's a sphere, which is a ball, and this is the formula for that. And really, you only have one number, which is a radius. And notice it's cubed, not squared. So if you were putting this in a calculator, you would say 4 times pi times radius times radius times radius, and then you would divide all of that by 3. And that's it. That's all the stuff. We'll have a couple of quizzes to check this. Make sure you do all of your homework. Make sure you do your exit slips. Come and ask for help if you need it, especially if I'm not there to teach you. And then before we leave school for Christmas or for spring break, we're going to take a test. But don't worry about it. We're not going to score the test till we come back, and then we're going to score it together and then make corrections so that everybody passes this unit test. All right? I'm sorry this message was a little bit longer than normal. From now on, when I miss something, I won't explain so much. I'll just do the lesson and let you work on your own.